Good afternoon, class. We are looking at Chapter 3, Derivatives, Section 3.2, the derivatives as a function. The derivatives as a function. So we looked at the derivative and rates of change previously, and tangent lines, and now as a function. So again, quick reminder, we are looking at 2 points. A rise over run gives us the slope, or delta y over delta x. There are various ways of looking at that. If we go with a and x, then this is the format. If we go with a and the distance of h creates a plus h, we go with this format. And if we call this b, this becomes f of b, we go with this format. Everybody remembers that. As q approaches p, we get to the red line, which is called the tangent line. The blue lines are the secant lines. So this is how you find the slope of a tangent line. You take a limit. And the way you approach it, well, if you go with this one, x approaches a. If you just want to stick with m of pq, q approaches p. We're talking about the blue lines, the secant lines versus the tangent line. If you go with this format, h approaches 0. And that's it, basically. Now, we want to come up with the equation of a line. There are 3 different methods. And if we use this pair, the equation of a tangent line becomes y minus f of a equals f prime of a times x minus a. And as I mentioned, you don't have to memorize. You just stick with point slope. Y minus y1 equals m times x minus x of 1. That would be the best course of action. So this is f prime of a, the derivative at a specific point. If you recall the last question we did, I kept it at a instead of changing the a to a specific number. And that really is the concept known as differentiation in general. Here we change our point of view and let the number a vary. If we replace a in equation 1 by a variable x, we obtain the following: f prime of x rather than f prime of a is the limit of f of x plus h minus f of x over h as h approaches 0. It's important to know this is the differentiation function. This is the derivative at a specific point, which represents the slope of a tangent line at that point. This represents, in essence, infinitely many different slopes. Now, given f of x, then some common alternative notations for the derivatives are as follows. F prime of x equals y prime, dy dx, df dx, d dx of f of x, d, capital D of f of x, capital D sub x of f of x. These are different ways of saying the same thing, everybody. These are different ways of saying the same thing. I can't emphasize enough, okay? And what happens here, the symbol d and d of x, d dx are called differentiation operators because they indicate the operation of differentiation, which is the process of calculating a derivative. We can rewrite the definition of a derivative in Leibniz's notation in the following format. dy dx is the limit of delta y over delta x as delta x approaches 0. A function is differentiable at a if f prime of a exists. It is differentiable in an open interval. The endpoints are not important. The open interval may be a to b, or a to infinity, or negative infinity to a, or even negative to positive infinity. If it is differentiable at every number in that interval, if it's differentiable at every number of that interval. So that's extremely important, everybody. All right, let's look at an example which we did previously, and that is finding a tangent line. How do you find the equation of a tangent line? You need two things. You need a pair and you need the slope. And I'm going to get the slope first. Rather than using f prime of a, we're going to go with f prime of x and then plug in it. So f prime of x, according to this definition, is the limit of f of x plus h minus f of x over h. So f of x plus h, square root of 3 times x plus h plus 1. F of x is itself. So it's very straightforward. If you plug in, you get 0 over 0. The technique would be, obviously, the conjugate, because you're dealing with a square root. So all you have to do, change this to a plus sign, multiply, and divide by it, because a minus b, its conjugate is a plus b. Their product is a squared minus b squared. So what happens is, this comes out of the radical minus this one. And the denominator, you always keep it as a product because h approaching 0 and you're hoping to get rid of it. The next step is simple. Everything is algebra. We need to simplify. So we are going to distribute 3x plus 3h plus 1 minus 3x minus 1. 3x and negative 3x cancel each other. Positive and negative 1 cancel each other. And the numerator has only 3h. We can get rid of the common factor of h. And now what happens if I apply the limit? So everything that you see is algebra. You could have just written without the limit, and now apply the limit by replacing the h with 0. If I replace the h with 0, I hope everybody can see this becomes 3x plus 1, which is the same as this one. So you have two of the same thing. Notice this changes to the same thing. Now you have two of them, and therefore f prime of x is 3 over 2 square root of 3x plus 1. We need two things. We need the slope, and we need the pair. As I've told you before, they don't have to give us a pair. They gave us x equals 8. So we can find the pair. Can anybody tell me what is the pair? X comma y. This is
8, 5.
beautiful. So this is f of x or y. If I plug in 8, I get 3 times 8, 24. Plus 1 is 25. Square root of that is 5. So plug in. And that gives you the y coordinate. Now, if I plug in 8 here, I get the slope. So again, this is 25. So the square root is 5. 2 times 5 is 10. 3 over 10 is my slope. Very straightforward. As I said, you don't have to memorize the equation of a tangent line. Rather, y minus y1 is m times x minus x sub 1. So y minus 5 equals m 3 over 10 x minus x sub 1, which is 8. And it's elementary algebra. Just distribute. You get 3 over 10 times x. And if you multiply these two, you get minus 24 over 10 or minus 12 over 5. I'm going to move the negative 5. And add it to 12 over 5. 5 is 25 over 5. And we get this final answer. Now, reminding you, this is the equation of the function f of x. The pair belongs to that. And this is the equation of a tangent line. This is the point of tangency, so it belongs to that. If I plug in 8, I should get 5, and I do. And what it means is that in this process, we didn't make a mistake. It doesn't mean anything else. It doesn't mean that we came up with the correct answer here. It says this process was done correct. We're going to get a couple more examples later on, but for now, let's switch gears and let's go with the graph of a function. Given, how do you come up with the graph of its derivative, or better yet, sketch a graph, a rough sketch? To do that, pay attention to the easy parts. First and foremost, peaks and valleys. So here's the local max, local mean, and if I were to look at those points, tangent lines are horizontal lines, and the slope is 0 for them. Then we have increasing and decreasing parts. So this portion of a graph and this portion of a graph is increasing. And increasing means f prime must be positive. This portion of the graph is decreasing, which means f prime must be negative. So we need the piece of information here. Let me erase the mess and show you the idea here. As I mentioned, the function is decreasing here and here. F prime is negative, increasing here and here. F prime is positive. So here's decreasing, here's increasing. By the way, this point class, they have pinpointed it and they did their best to draw a tangent line, and they pick 2 points and they calculate the slope of that line. And what happens at this point, which x is 5, the y will be 3/2 for its derivative, okay? Just to give you an idea. So what happens, these 3 points correspond to 0 on the graph of f prime. So for those, this one, this one, and roughly this one. So we said this portion is decreasing, so it has to be below the x-axis. And this portion is decreasing, so it's below the x-axis. But remember, at point C, it comes back to 0, so roughly that. And this was an increasing, means above, means f prime is positive, means above the x-axis, but it has to come back to 0. And the same thing here is increasing, so above the x-axis, and it remains above. So let me again clean up the mess and show you a better graph. So this is how you come up and sketch the graph of a derivative function roughly. So simple examples you should be able to handle. For example, if you have a line, just remember, all you have to do for a line, calculate the slope. So any line that they give you, if you calculate its slope, let's say the slope is 5, then you draw a horizontal line y equals 5. Let's say the slope is negative 3, then you draw a horizontal line y equals negative 3. So that's the case. So all you have to do, calculate the slope here. And to do that, rise over run. So if I pick 2 pairs, clearly this is 0, 0. And this one is 1, 3. By the way, look at this number is 1, this is 6. So the scale along the x and y, they don't have to be the same, and they are not. So 3 minus 0 over 1 minus 0 gives you the slope of 3. And so corresponding to this, y equals 3 is the graph of its derivative, which is simply a horizontal line. So it's a very simple example in this case. For this one, we start with the easy pairs. This point and this point clearly have horizontal tangent lines because that's the local max, that's the local mean. And just to give you an idea, so this corresponds to 0, this corresponds to 0 on the graph of f prime. This portion as well as this portion increasing f prime is positive, and so it's above the x-axis here roughly, here roughly, and in between. In between, it's decreasing, which makes f prime negative, so it's below the x-axis, but it has to come up, and it looks something like this. Again, pay attention to the easy pairs. For this one, clearly, you have a horizontal tangent line at this point. This part is increasing, meaning f prime is positive, so must be above the x-axis. This portion is decreasing. F prime is negative, must be below the x-axis, and the graph looks like that. So a rough sketch is good enough. The next topic, how can a function fail to be differentiable? There are three ways. When we have a sharp corner, when we have a discontinuity, when we have a vertical tangent line. When we have a sharp corner or kink, the graph of f has no tangent line at this point. The left and right limits are different. We have a discontinuity. If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. This is jump. When the limit of f prime of x as x approaches a blows up to infinity or negative infinity, that's why we have the absolute value, that we have a vertical tangent line. So the graph of a function f of x has a vertical tangent line at a point a comma f of a, if and only if, that's how it's read. The limit of f prime of x as x approaches a is negative infinity or positive infinity. Both sides have the same result. In this case, one side is infinity, one side is negative infinity. It's called the cusp. And when the graph of the function becomes vertical and then virtually doubles back on itself, such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at a and f of a, if and only if the limit of f prime of x is infinity as x approaches a from the right, but from the left is negative infinity or vice versa. Both sides do not have the same results. And that's the key that we want to pay attention to. Here's a simple example, everybody. We want to know where the graph of the function fails to be differential. Okay. Clearly, at x equals 0, we have a discontinuity, so it fails to be differential. Number 3, that's a vertical tangent line. If you mix it up with a a sharp corner, that's okay, but I'm going to explain the difference in a moment so you can clearly see the difference between the two. Second graph, clearly we have a discontinuity at this point, namely x equals -1. What about this one? At x equals +2, we have a sharp corner. Now, here's what I want you to notice. In the case of a sharp corner, you are clearly looking at a V shape or a V shape that is upside down. But if you are looking at a tangent that is a vertical tangent line, look, seems to be going up in both ways. Now, if you don't recognize that, it's not that big of a deal, but this is normally a shape that is a V shape. Again, we are given a graph of a function and we want to sketch the graph of its derivative f prime. So remember what I told you. If you have a line, all you have to do calculate its slope, and that is y equals that slope, that is the derivative function, and the graph is a horizontal line. Remember, we have 1, 2, 3, 4 line segments here, everybody. We have 4 line segments. So for each line segment, I need to calculate the slope. So let's throw in some numbers. Let's say this is at -3, 1, -1, 0, 1, 1, 0, 3, 1. Let's assume that's the case. They seem to be the case, right? The tick marks appear to be that way. And so rise over run. So for this line segment, I'm going to do the calculation. 0 minus 1 over -1 minus -3. The numerator is -1, the denominator is +2. So the slope m equals -1/2 for this piece. And perhaps you recognize for this piece is a positive of that. This piece easily can be calculated as m equals +1. And for this piece, then it must be -1, as you can see. Okay. So let's assume this was a line, not a line segment, and it would continue indefinitely. Then I would graph the line with the equation y equals, and by the way, this is m equals -1. I think I mentioned that. So for this one, y equals -1/2, and I'm done. Never mind the rest. I'm just looking at this piece, right? Y equals -1/2. So if this is the line that continues indefinitely on both sides, then I have a line y equals -1/2, and I'm done. However, as you can see, we have a sharp corner here, and it stops. Therefore, it's not differentiable at that point. So that's what we have instead. If I look at the second line segment, then y equals 1, and it stops here. Y equals 1. For the next one, y equals -1. Again, this is not too scary, everybody. And the last one, y equals 1/2. So again, just this one corresponds to this one, okay? this one, this line corresponds to this one, so on and so on. So that's the graph. Let me clean up the mess. So those are the lines we need, and we are going to cut them into line segments because they stop here. This is a line segment. So those are the line segments. At the endpoints, they're all having holes because they are not differentiable due to the fact that the endpoints are all sharp corners. Sharp corners, everybody. All right, let's go back to differentiation using the definition. This is the last section we use the definition. So again, just for the sake of argument, and some students knew that even for the exam, but you can't use it for this section when you do the homework. Some of you may know if you want to differentiate, this is 5, but we have to do it with the definition. So limit of f of x plus h minus f of x over h as h approaches 0. If we use that, the top is 5 times x plus h plus 1 minus 5x plus 1. That's what we are taking the limit. And therefore, all we have to do is just to simplify using algebra. So let's distribute 5x plus 5h plus 1 minus 5x minus 1. So we're going to simplify the numerator. 5x and negative 5x cancel each other. 1 and negative 1 cancel each other. The only thing left is 5h. Now, h and h cancel each other. And therefore, the limit of 5 as h approaches 0, simply, it's a constant 5, as you know. We're going to do the same thing here using this definition. The limit as h approaches 0, f of x plus h means 2 over x plus h minus f of x is itself. And by the way, if you plug in, whether you do it here or here, you end up with 0 over 0. So if you plug in everybody, this will give you 0 over 0. This will give you 0 over 0. Simplification did the job. This is a complex fraction. LCD, the least common denominator, does the job. So x times x plus h is the LCD. We're going to multiply the top and the bottom by that. So when you multiply it by this, simply put x plus h goes away, becomes 2x. If you multiply it by 2 over x, x and x goes away, minus 2 times x plus h. And as always, the denominator is not touched. We keep it in the product form because h approaching 0 is a problem we want to get rid of. So what happens? 2x minus 2x minus 2h. These two cancel each other. So the numerator is only negative 2h. We repeat the same thing, only negative 2h in the numerator. H and h cancel each other. And so we end up with the limit of negative 2 over x times x plus h as h approaches 0. Now, this is the only calculus step. Everything here, you could write it without the limit and simplify. Over here, you must put the limit and apply. That gives you 0. So x plus 0 is x, x and x is x squared. So minus 2 over x squared is the final answer. Very straightforward using the definition of it. Here's the next one. And again, it goes pretty fast with the formulas that we discuss next time. But for now, we are going to go with the definition. The next section we learn that is 7 times 2x, which is 14x. But let's do it by putting into definition the limit of f of x plus h, 7 times x plus h quantity squared plus 4 minus f of x, the same expression, over h as h approaches 0. So all you have to do is simplify this expression, algebra, algebra, algebra. You should know x plus h squared is x squared plus 2xh plus h squared. So we multiplied by 7. In other words, remember that we are looking at a plus b squared, which is a squared plus 2ab plus b squared. That's what this is all about. Let's distribute. We get 7x squared plus 14xh plus 7h squared plus 4 minus 7x squared minus 4 in the numerator. 7x squared minus 7x squared, they cancel each other. Positive 4, negative 4, they cancel each other. So we are left with this. And as you can see, we can take out 7h as a common factor, but I'm just interested in h class. I want to get rid of the h. So I'm going to take out the h only. Again, I want to make sure that everybody knows that the proper form of factoring would take out 7h. But I just want to get rid of the h, as I mentioned. And now, when you replace the h with 0, you're left with the final answer, 14x. And that's the final answer.